We're going to start this lesson by reviewing the terminology that I've used in the videos 1 through 7. So a mixed number is created using two types of numbers. Let me write down an example. 5 and 2/3. A mixed number is composed of a whole number and also of a proper fraction. So a proper fraction occurs when the numerator is smaller than the denominator. The number on top is smaller than the number on the bottom. An improper fraction occurs when the numerator is larger than the denominator. So three things here. A mixed number is made up of a whole number and a proper fraction. Now, opposite of a proper fraction is an improper fraction. And in the first few lessons, we learned how we could rewrite an improper fraction as a mixed number. Let me quickly do this. The numerator goes inside the division box. The denominator goes on the outside. 5 can fit into 11 without going over a maximum of 2 times. I chose the number, I multiply, and I subtract. And then going clockwise, I can see that I'm able to rewrite 11/5 as 2 and 1/5. Then we moved on to reducing, also known as simplifying fractions. And in the last lesson, we talked about greatest common factor, also known as GCF as an acronym. So GCF, let me just go right over here. GCF, let me do a very simple one. Let's do the GCF of 10 and of 16. So greatest common factor, I'm going to write down all the factors of 10. So to achieve that, in my mind, I'm going 1 times 10 is 10, and 2 times 5 is 10. Now, in between 2 and 5 are two whole numbers, 3 and 4. 3 does not evenly divide into 10, and 4 also does not evenly divide into 10, so I've listed all the factors of 10. Let's go on to 16. 1 times 16, 2 times 8, and 4 times 4, but we only have to write 4 one time. So now that I've listed all the factors, the GCF can be found by finding the common values here, and we can see common values would be 1 and 2, and the greatest of those common values is in fact 2. I also showed how you could achieve the GCF using what's called the prime factorization trees. And although a lot of students are more comfortable with this because they've probably been exposed to this throughout elementary school, as you get into high school, it's important that you understand prime numbers. Prime numbers is another one of those terms. So prime numbers are numbers that are identified as prime if the only way to achieve them is taking 1 times itself. For instance, 2 can only be achieved by taking 1 times 2. 3 is prime because the only way to achieve it is 1 times 3. Now, why is 4 not prime? Because outside of 1 times 4, we can also have 2 times 2. How does that help us in constructing a prime factorization tree? So to achieve 10, I could take 1 times 10, or I could also rewrite it as 2 times 5. It's your choice. There's no wrong, as long as you choose two numbers that multiply to give us, in this case, 10. Let's go with 2 and 5. Now, the nice thing is 2 is prime. Why? Because I can take 1 times 2. And 5 is prime because I can also take 1 times 5. So I'm going to circle these. These are the branches of the prime factorization tree, and at the end of each branch needs to be only prime numbers. Now 16, I could take 1 times 16. Maybe somebody else watching this video would take 2 times 8, and others would take 4 times 4. None of those are wrong. I'm going to go with 2 times 8. Now 2 is already in prime form because the only way to achieve 2 is 1 times 2. How do we achieve 8? We could do 1 times 8. We could do 2 times 4. It's your choice. But you need to continue to break it down until only prime numbers exist. So 2 times 2 would achieve 4, and we know 2 is 1 times 2. So each one of the branches at the end can only be prime numbers. Now I'm going to write 10 and 16. And I'm going to list out these values. So we have 1, 1, 2, and 5. I'm putting the numbers in ascending order. That means smallest to largest. Over here, I have 1, 2, 3, 4. I have 4 1s, and I have 4 2s. So if I multiplied 1 times 1 times 2 times 5, I'd achieve a value of 10. And if I have to multiply these values, I would also get an answer of 16. How does this help us determine the greatest common factor? So we're going to circle what do they have in common. And then once we circle what they have in common, we are going to multiply these values. So 1 times 2 times 2, the GCF of 10 and 16, 1 times 1 times 2 is in fact 2. What we're going to move on to now is we're going to move on to the LCM. So we just talked about the GCF, which is an acronym or an abbreviation for greatest common factor. LCM represents least common multiple, or sometimes teachers say lowest common multiple. I often see students get confused between the words multiple and factor. So before I jump into defining the least common multiple, I'm going to grab a sticky note and just demonstrate to you the difference between factors and multiples. When we say factors, and let's choose a little bit larger number. We've gone over this multiple times in the videos, but factors are what whole numbers multiply to achieve, in this case, 24. 1 times 24 is 24. 2 times 12 is 24. 3 times 8 is 24. 4 times 6 is 24. Each of those numbers in the list evenly divides into 24. When you see the word multiple, multiple is when we're going to take a number, let's choose an easier number, like 3. And we're going to count by 3s. And so I'm going to describe a couple ways we can do this. So you can go 3 plus 3. So the first multiple is 3, and then 3 plus 3 is 6. Add 3 to it again, we have 9. Add 3 to it again, we have 12. So many of us will just count in our head. 3 plus 3 is 9, plus 3, plus 3, plus 3, and right? And you just continue this, and it goes to infinity as we continue to add 3. Others will use their ability to apply multiplication. 3 times 1, 3 times 2, 3 times 3, 3 times 4, and so on. So let's jump into writing down multiples. So we're going to write them down in ascending order. Ascending order means from lowest to highest. And as I just shared with you, there's no end here. It doesn't stop at 18. It doesn't stop at 20 or 24. It just keeps going. But for the sake of time, right, because we can't continue to count and count and count if there's an endless number, is I'm going to write down the number 2, and I'm going to write down a few multiples past it. And then what I'd like you to do is I'd like you to think, what would I fill in for the next 4 boxes? So this is 2 plus 2 is 4, plus 2 is 6, plus 2 is 8, plus 2 is 10, 12, and 14. And again, you can also think of this as multiplication. 1 group of 2, 2 groups of 2, 3 groups, 4 groups of 2, 5 groups of 2, 6 groups of 2, and 7 groups of 2. Hopefully that seems pretty easy. I'd like you to try one on your own right now. So let's start with 5. I'm going to write down 5 and 10. And I want you to think what would be the next 3 boxes. So again, you can think of this in terms of adding or multiplying. If I'm adding 5 to get 10, adding 5 to get 15, adding 5 to 20, adding 5 to 25. Or maybe your brain works more in terms of multiplying. 1 group of 5, 2 groups of 5, 3 groups of 5, 4 groups of 5, and 5 groups of 5. Let's move on to the next part. Write the common multiples of 3 or 4. It does not use the word least. It just wants us to practice listing multiples and then identifying what do they have as common values in both lists. So I'm going to start by writing the multiples of 3. 3, 6, 9, 12. And I'm going to continue again to either add 3 or multiply by 3. So 1 group of 3, 2, 3, 4, 5 groups of 3, 6 group of 3. And again, multiplying or adding, however your brain works. I'm going to do the same thing with 4. Okay, now Here I can see I want to fill in the boxes, and this means it continues to go, but I only need to list the first three. So what's the first common number we see in the list? And we want to write this in from least to small, or least to greatest, which is ascending. So there's not a 3, there's not a 4. Here's the first number they have in common is 12. The next number they have in common is 24. And let's just keep going here. So on top, if I add 3, I'm up to 27, 30, 33, 36. Down below, I'm at 28. Add 4, I'm at 32. Add 4, I'm at 36. And there's the first three common multiples of the values 3 and 4. If you understood the last example, I'd like you to press pause and to write down the first two common multiples of 5 and 6. Again, we don't see the word least. That's going to come up in the next example. When you've completed identifying the first two common multiples, then come back and press play in this video. Okay, multiples of 5. 5, 10, 15, 20, 25, 30, 35, 40, and let's do 6. We have 6, 12, 18, 24. Oh, I see one in the common there. There's a 30. And now I can easily identify multiples of 5, so I'm going to keep going with 6. We're at 36 times 7 is 42, times 8 is 48. Add another 6, we're at 54, and there we're at 68. I know here that I would come up with 60. The difference between the previous two examples and this particular example is now they've inserted in the word least. So we're still going to identify a common multiple, but it's going to be the first common multiple we see between the list of multiples of 5 and also of 9. So 5, that's not a multiple of 9, 10, 15, 20, 25, 30, 35, 40, 45, 50, and so on. Now we have 9, 18, 27. In my mind, I'm going 1 group of 9, 2 groups of 9, 3 groups of 9, 4 groups of 9. And you can see how important it is to know your multiplication facts. And you can see 45 is the first common multiple of the list of values for 5 and 9. So this answer would be 45. And they probably would write it using the acronym LCM for least common multiple, or your teacher may say lowest common multiple, and that would be 45. In this last example, you're going to do the exact same thing as the previous example. It just looks different. So now they give you a pair of numbers. They give you the value 8 and the value 10, and they want you to identify the LCM, the least common multiple. And so I'm going to start with 8s because I don't think I need to do the list of 10. I know 10, 20, 30, 40, and so on are the multiples of 10. So I have 8, 16, 24, 32, and 40. I know 40 is a multiple of 10. It is the least common multiple. At this time, please go to your workbook and you're going to complete the problems on page 10 and 11.